What's up, many drifters? How you all doing? In today's video, I want to talk about the Tommy Racing Car version 2, also known as the TRC2. And before we start, I want to give a huge shout out to Chan from ChanRc for providing me with this piece of art. The least I can say about it. Now, usually I don't do videos. I stick to pictures just like the others. But whenever I come across something unique and special, I feel that pictures will not do it justice. And I feel that the mini drifting community so far is all or mostly concerned about the looks, the bodies, the wheels, and there's no much posts regarding build quality, setup, tuning, unlike the 110 scale community. So I'll try to get more into it. I'll try to get more technical today. Now, this video has been long overdue for me. I decided initially to shoot it about 3 weeks ago, but then I realized it will take me longer time just to tune the chassis, to get it to work perfectly. Out of the box, or initially after you put it together, it will drift okay, but not as good as if you take an extra time to tune it. And I feel that a lot of people will actually get frustrated or even give up on this chassis before they can get it to run perfectly. And the reason for that is there's no building manual for this thing. There's only a Chinese video at Bilibili, and good luck understanding that. So I said it's better, or I thought it's better to tune it, get it to run correctly, then share my setup with you guys. The TRC V2 is a Chinese design car, but it's fully made in Japan. And that's what explains the high quality that you will receive once you purchase one of these. As far as material goes, it has 5 materials, building materials. The first thing you can see here is the base plate and the side plate, which are made of carbon fiber. Then you have all the purple components that you can see. They are 7075 aluminum. And then you have some components which are made of brass, such as the shock barrels, the rear toe links, and the front steering stopper pins. These pins. These are the brass components as far as I can tell. And then you have components which are made from stainless steel, such as the drivetrain itself, the gears, which are helical gears. I've never seen this in a car before, only in RC helicopters, and it's buttery smooth. The final material, of course, is plastic, and the only plastic components that you'll see in the entire chassis are 2 components. The ball links all around are plastic, and the shock spring retainers, the plastic piece at the bottom that will prevent the spring from shooting out. These are plastics also. As far as features goes, the TRC has all the basic features that you would expect from a premium chassis, such as adjustability for the front toe, the camber. It has a bulkhead screw here, which you can undo. I already loosened it, and then you can simply slide the whole front assembly to adjust your caster, as you can see here. Then you have your servo mount, which is also adjustable. It can slide forth and back, as you can see here, and this will adjust your acronym. If you don't know what acronym means, the acronym simply is the relationship between the 2 front wheels throughout the range of motion. And the idea, or ideally, you want your wheels during full lock, either you want your leading wheel to be at an acuter angle or more angle than the trailing wheel, or you want them to be parallel to each other during full lock. And when you slide your servo mount, that will adjust it for you. For example, this way my wheels are almost parallel during full lock. Now if I go acuter angle than this, for example, if I adjust it this way, this car will spin out immediately, because now my trailing wheel is at almost 90 degrees, but my leading wheel is at a less angle. So this wheel will fight the action of this wheel, and your whole chassis will spin out immediately. So this is the functionality or the uses for the sliding servo rack. Other than that, when we go in the rear, same shocks at the front, IFS shocks, and then you have this piece, the rod that goes in the middle. This is the most important feature in this chassis, in my opinion. And what that does is, this is a piece of a metal, again, aluminum rod that connects the rear toe links via ball link, and it goes underneath your servo mount, and it attached to your servo horn via a screw. There are various positions that you can set the screw at, and what that does is, when you turn your steering, take a look at the rear toe. When you turn your steering, your rear toe also changes, and you can control the direction at which should the rear shift, either rear toe out or rear toe in, and you can also control the amount or the volume of motion at which you want your rear toe to change. I will not be talking about the entire building steps, that will make it a long video. Instead, I'll keep a link for the original Billy building video down in the description. Just make sure that you watch it a few times, follow it slowly, and you will be okay. Instead, I'll try to address some of the steps that kept me scratching my head, and I'll try to save up some time for you guys. So before we start with the setup, I'd like to give again a huge shout out to ChanRc, as well as Tuba Elaine Wong, for helping me with the setup as far as translating portions of the building videos and guiding me through the build. Now we'll start from the front to back. The first thing you'll see at the front here is, in your upper and lower arms, you have this brass spacers. At initial glimpse, they'll look similar to you, but there's a difference between them. There are two sizes actually that you receive in the kit, 2mm and 1.5mm. Make sure you keep you install your 2mm at the top and the 1.5mm at the bottom. Initially, I was not careful. I got them messed up. I placed the 2mm up here and another 2mm down here, and it threw out my entire steering geometry off. So make sure you don't do the same mistake. The second thing is, if you take a look at the front knuckles itself, there are two mounting points at the top here. There's an outer mounting point and inner mounting point. Make sure that you use the outer mounting point, not the inner mounting point. And the reason for that is the steering geometry itself. If you take a look at the steering here, in all the other cars, the idea is you adjust your steering in a way that your leading wheel is at 90 degrees to the ground, correct? In the TRC, it's the other way around. You should adjust your steering so as your trailing wheel is the one that at 90 degrees to the ground at full lock, like so. And you can see through the base here, the leading wheel on the other side has a positive camber. So this thing, I struggled with it for a long time. I was trying to get my leading wheel to be parallel, and it's nearly impossible as far as I can go. The second thing is, we talk about it, is your caster screw. Your caster screw, you adjust it again to gain a 90-degree contact patch at your trailing wheel. So that's that. And then you have your steering links. There are 3 mounting positions in the servo horn for the steering link. I use the front hole. I've never tried the second or the third hole, but it's been working great for me. And the steering link itself, the length of the link itself is very important. There is a point at which if you go under, your whole steering will lock on both directions. I think it was below 5mm or so. So if your link is less than 5mm, your steering will jam on both directions. At the moment, my links are 6mm exactly. And if you took a look at the bottom here, there's a second link. At the bottom, you have 2 links with the knuckle. The second link, the stabilizing arm, is exactly 4.8mm. That's it. And then after that, we go to the sliding servo rack. You adjust your sliding servo rack to get the acronym, like we said before. Just simply, after you finish your caster and link steering links and adjusting stabilizing arm link. If you after you set them all, you go to your servo, undo the screws, take a look at the chassis from behind, and then slide your servo until you get a parallel steering, like so. At this point, you tighten your servo mounting points, and with that being said, your front assembly is almost done. Now, the shock itself, inside the kit they provide you with three set of shocks. You got hard, medium, and soft. So you receive 4 hard springs, 4 medium springs, and 4 soft springs. The choices with regard to the springs depends on the weight of your electronics, the weight of your battery, and of course the weight of your body. I went with the hard spring at the rear and the medium spring at the front because I'm using a heavy die-cast body. If you're using a plastic body, like an auto scale body or model kit body, you want to go soft spring in front and medium spring in the rear. That's easy. You can tell if the springs are off or not, so it's not a big problem. You can adjust it easily. Then we go to the back here. You have the most important adjustabilities in the back, which are the rear shock link, the brass link. This link has to be at a specific length, and if you don't do it correctly, if you do it longer than it should, your whole suspension travel will be affected. Meaning, you see, this link is connected from the lower arm to the rocking arm. This arm is mounted via ball bearing to the rear diff outer wall or outer plate, and on the top here we have a ball bearing that connects to the shock. So the mechanism is, whenever the tire is lifted, it will push the rocker arm forward. So the way you adjust this is, of course, first of all, you have to remove your shocks before you do this. Then squat your chassis to the bottom. Of course, if you remove the shocks, the chassis will automatically hit the bottom like this. And from this point, you calculate or measure the length between that ball bearing, that ball link at the bottom and the ball link at the top, and you adjust your link accordingly. Let's say you screwed it up and your link were longer than it should. So for example, imagine if you increase the length of your link, the rocker arm will be pointing forward like this or so. But at the same time, the wheel will be touching the ground. So when you end up setting up your chassis, your travel will be limited. It will move like this only. The range of motion will be limited. You want the full range of motion, all the way from the back to the front. So that's one thing you have to keep in mind to get the full range of motion in your shocks. The other thing is the rear toe links itself. Now, these toe links, they are stainless steel links, and they are provided in the kit as a straight link. Now, in the video, in the original building video, the instructor showed that you have to make 2 bends. Basically, you have to create a shallow S shape in order to avoid the link itself to come in contact with the rocking arm, which will prevent your movement. Now, if you are nervous about bending your links, because it's a 1 millimeter diameter or 1 millimeter diameter link, so it's very brittle, it can break easily. If you are nervous about bending those links, that's okay, you don't have to do it. The only thing you have to do is, you see here, this is the position where you should mount your ball link. The only thing you have to do is reverse that position. So install your ball links at the bottom here, and what that does, it will give you an extra room for movement without the link being jammed by the rocker arm. For example, see here, this is the full motion, and still I have about 3 millimeter away from the rocker arm, so you can go that way. Other than that, the adjustability for the rear toe rod, this one we'll have to remove the servo horn and the servo itself to talk about it. I'll be back. Now, before we talk about the rear active toe and how to adjust it or how to set it up correctly, we have to talk about the servo mounting blocks and the servo horn itself. Now, if you take a look here, there are two parts on each side required to mount your servo. There is inner blocks and there is outer blocks. See, the inner blocks has only one hole, which you can adjust to, which you screw one screw on both sides to fix your servo in position. And there's the outer mounting blocks. The outer mounting blocks has two holes and there's slots, so the whole block moves up and down. But pay attention to this. If you see the mounting hole here, which will adjust to the center plate of the chassis, it's off center, it's not on the center. So the way you have to install it is with the screw pointing downwards. Like if you flip this part and you end up with the hole mounting upward or slightly shifted to the up, the servo horn will not sit flat on the steering rod. The servo has to become or sit flat in close relation to your horn. If it's up, you will end up with a space, a gap between the servo horn and the steering rod, which will not work perfectly. So pay attention to that. I made this mistake also at the beginning. The servo horn itself is made out of aluminum 7075. It has a center cutout that is specific for 25 teeth or 25T spindle servos. So if you have a servo that is below 25, like 24, I think my DRZ V1 had a 24T servo. I tried to fit it here and it will fit loosely. It will not fit snug. And if you happen to have a servo with a higher, like 25 or 26 or 27, I'm not sure even if those servos come at 27T, it will not fit because it's a metal on metal. You cannot just push it or snug it. You will end up breaking your servo gears. So this is something you have to keep in mind whenever you trying, or if you decide to buy one of these. Your servo has to be 25T. And as far as I can tell, all the servos that look like this, meaning it has a black casing and the purple line in the middle, they are the same. The TRC, the XRX, the AOL, the BM Racing, they are all the same servo, just rebranded. So this is something to keep in mind if you are planning to buy this chassis. The other thing is there are two slots at the servo horn, right? There's a front slot and there's a rear slot. These slots are designed for you to insert a 2mm by 6mm screw with a 2mm nut on the other side, and this will control your direction of the rear toe. Now, if you take a look at the rear toe rod itself, it's attached to the base plate via ball bearing and a nut, 2mm nut at this point. So this is the pivoting point of the whole rod. The rod will move around this point, right? And just underneath it, you'll notice there's an extra hole here. This extra hole is also another option or another feature that you can run in your chassis. Now, regarding the whole active rear toe, you have three options that you can run. Option number one is by removing the screw totally. It's a 2x4 or 2x6, I don't remember, 2x6 I think, 2x6mm. You remove it and you insert a longer screw, something like 2x8 or 2x10. And the point for that is the screw will be so long to the point that it will go through the base and it will go through the rod itself. And what that does is it will fix your rod at the center. So your rear toe at this point is fixed. You adjust the rod at the rear toe and it will not move with regard to your steering, just like any other drifting chassis. So this is option number one. Of course, if you go with this option, you have to totally remove the screw, run it naked. Otherwise, you'll break your servo gears. Option number two. This is where it gets a little bit confusing. Just bear with me. I'll try to explain it as simple as I can. Let's say you want to run rear toe in, which is option number two. You achieve this by inserting your screw at the rear horn slot, just like it is now. Now, let's say if you want that you are going right side, you want to drift to the right direction. So it means your wheels will be turning to the right direction, but your servo horn will go to the opposite direction, right? Like so. And because the screw is pointed or fixed at the rear, the screw will go to the opposite direction, to the right side, meaning it will push the center rod to the right direction. Let's see here. So your center rod is pushed to the right direction. Because there's a pivoting point here, the rear tire will be pushed to the opposite direction. So it's a rear toe in. Your leading rear wheel is pointing inward in the opposite direction of your front wheels. This is option number two. Option number three, same scenario, but opposite directions. Now option number 3 is a rear toe out. You achieve this by inserting this screw and nut up top at this slot. Again, you're turning right, you have your screw now at this position, your servo horn will turn to the left side, which means your screw is on the left side. The screw will push the rod to the left side, and because there's a pivoting point here, your rear toe will be pushed to the outside. So you end up with your rear outer wheel toe out, or going in the same direction as your steering. This is rear toe out, the third option. Now, the question is, which option should I run? And honestly, I believe that option number 1, which is canceling out the rear active toe, defies the whole purpose of why you buy this chassis in the first place, right? So you have to either run rear toe in or rear toe out. And we had a debate at Facebook post before, and Elaine Wong explained it very scientifically. Before that, I forgot to mention one point. This is a rear motor mount chassis, meaning your motor is mounted at the back here, and the mounting plate itself is adjustable. There's 2 screws underneath the sprue gear here, which you can loosen, and then the whole plate will rotate from 90-degree upward to 90-degree horizontal, and all the way in between. You can adjust at any position you like, and each position will affect your handle characteristics and weight distribution. I choose the front or the higher position because of my body. Anyway, because the weight or the motor is mounted at the back, it creates something called pendulum effect, meaning the whole weight of the chassis is at the back. So the moment you initiate your drift, because of the extra weight at the back, your rear end will tend to go forward, meaning it will spin out very fast if you are not used to this weight distribution. So in my opinion, the rear toe in is the best option you can go about setting up your chassis, because as we said, the weight at the back, right? Let's say we are drifting to this side, your counter steering, and because of the weight or the heavy weight of the motor, your rear end will tend to move forward. But you have your rear toe in, meaning your leading tire at the back is pointing in, which will in turn cancel the pendulum effect of your motor, and it will help you drift at straight line rather than spinning out. This is the rear toe in. Let's say you decided to go with rear toe out. Same thing. You are turning, drifting at this direction. Your weight is dragging you forward, but now you have your rear toe at the same direction of the weight, which means the rear toe out will actually help you to spin out. It will counteract the whole action. It will defy the whole purpose of having a drift chassis. But there are some ways that you can use, or there are some situations the rear toe out are better. If you are running bad tires, grippy tires, or if you are running on a grippy surface, it's easier to have rear toe out to help you initiate the drift easier. I tried that on a carpet. It drift better, much better with rear toe out because of the high grippy surface that I'm running on. So it's up to you, and it's up to the surface that you are running on. Now, there's another building step that might leave you scratching your head, is how loose or how tight should my central rod nut be? And the question and the answer that I found out after experimenting is it should be tight enough, or loose enough to allow free side-to-side movement with little bit of restriction or friction, but it should be tight enough to not move up and down so freely, because otherwise you'll end up scratching the base plate here and creating an extra frictional point, which in turn will spoil your servo or even strip your servo gears. So, and initially I struggled to create that space. If you take a look here, you'll notice there is a gap between the rod and the base plate. Now, if this nut is not set up correctly, or it's too loose, this bar or this rod will be all the way down, scratching against the base plate, and the steering will not be smooth, and you will hear a lot of clicking noises when drifting. And the problem with that was I did not pay attention to the exact sequence of setup for the nut itself, or the attaching point or the pivoting point. And the setup goes like this. At the base, you should insert a 2mm spacer. In the kit, you will get one 2mm spacer, one piece, and it's very distinctive in shape. It's very bulky. It has a cutout in the middle and a grooving on the side. So you insert this one first. Then on top of that, you insert a 0.2 millimeter shim, which is also included in the kit. On top of that, you insert your rod. The rod you inserted with the ball bearing, it's a flanged ball bearing. You insert the flange on top. So the rod with the flange bearing on top, and on top of that, you insert another shim, 0.2 millimeter shim, and then you attach your M2 knot. And you tighten it in the middle, not too tight and not too loose. And if I describe it, it's more close to tight than it's too loose. So there's a little bit of friction or a little bit of resistance, slight resistance to it, and this is how you set up your center rod. Another feature that I forgot to mention is the rear dog bone. If you take a look at the rear drivetrain here, there is no dog bone. Instead, there's a male and female part. The female part is attached directly to your central gear, and the male part is connected to your wheel hub, right? So this part shifts in and out of the female hole. So, and what that does, for example, usually 128 scale or 124 scale come with a dog bone, which is fixed in size. So if you try to adjust your rear width or rear ride width, you have to buy another or an extra long dog bone. Usually the standard is 8 millimeter, right? And the upgraded part is 10.5, I think 10.5 millimeter dog bone, just to get a wider rear ride height. Now, because this is male and female, you can simply adjust your rear width without buying extra part. The upper link and the lower link screw are already long. You can undo them to get your tire, your rear hub outside, and because it's a male and female part, it will just simply slide out while maintaining full contact. So you don't have to buy any extra part to adjust your rear drive width. Another feature that I forgot to mention is how to adjust your rear or ride height in general. And now if you take a look at the back here, you will see that there are two holes at the top. They are threaded holes, 2 millimeter holes. And the idea is if you insert a 2 millimeter screw, it has to be a long screw, something like 8 or 2 by 8 or 2 by 10 millimeter. If you insert the screw far enough, the screw will eventually hit the shock arm, right? And as you tension the screw in, your rear height will go lower, as so. So this is for the rear. For the front, if you look at the center here, you'll notice there's 1.5 millimeter hole, also threaded holes. The same concept. If you insert a grub screw, 1.5 millimeter grub screw, as you create more tension, your ride height or your wheel arm will go up and your ride height will be less. Same concept. Now let's talk upgrades. And luckily, there's not much upgrades for the TRC. What you see here is what you get. It's a fully hopped up chassis by default, but there are three upgrades that you can buy. The first one is the brake calipers. Comes in two sizes, big size or large caliper and small caliper. The large caliper go up front and the small calipers go at the back. The second option is to buy a posting system, front and back carbon fiber plate with post and magnets that you use if you want to use model kit bodies. And the last option is regarding the servo itself. You can buy an additional servo cap. If you take a look here, the front portion of the servo, this cap, the black portion is big. It's about 4 to 5 millimeter, I think. It's about 5 millimeter high. And this, because of the servo position, it will interfere with your mounting of the body. I had to actually cut part of my body to accommodate for the height of the servo. Now, if you don't want to go through this pain, you can purchase an additional cap, which is smaller, about 1 millimeter cap. Chan has it, and it's very cheap. You can just replace the hole, take the 4 screws, pop out this top cap, and insert the small cap, and it will sit easier with anybody without having to modify it. Now, how you should install your electronics, at which position? If we take a look at the chassis, there's a limited space for any installation whatsoever. Keep in mind, this is the TRC2. There's another version, which is the TRC 2.1, which has an extra surface at the back here, which you can use to install your electronics. And the way I went about it is I placed my speed controller on the right side front, my gyro on the left side front, and my receiver on the left side rear. So this is the setup that worked for me. And regarding the battery, the best position for me was on top, behind the servo immediately. And I use it and I secure it in place using a Velcro. I tried to run it with the battery on one side, with the gyro on top and with the receiver on the other side, but I felt that my battery weight was heavier than the ESC and the receiver, and I felt that my chassis is a little bit tilted to the left side, or I don't know, maybe it's psychological factor. But the top battery mount was the best handling setup to me so far. With that being said, the most important question is, how does it actually perform? Well, let's see. So, what's the final verdict on the TRC V2? In my opinion, there's no such thing as a perfect RC car. Not even a perfect real car in real life, let alone an RC car. But the TRC V2 is near damn perfect. The downsides to having a TRC is that it's difficult to put together because there's no instruction manual. It's very hard to tune. It will take a long time for you to get it to drift correctly. And the other thing which I don't like, it's not even a design flaw, it's just a personal preference. The TRC is built after something like the YD2R or the RRX MST, which is a rear motor mount, which has the pendulum effect. Personally, I don't like the pendulum effect. I prefer a mid motor mount or a front motor mount. That's why I always, before I received this, I used to always drift my BMRX. It was my favorite chassis. But after I installed or after I put my TRC together and I tune it correctly, I really touched the BMRX again. Handling wise, this is the best chassis that you will ever drift at this scale. It has the best building quality, the best features. It's not even fair to compare it to other cars. I tried most of the cars in the market. I tried the DRZ with the BM kit. I tried the XRX. I tried the BM Racing. I tried the K989 modified by MJ Shop. And this is by far superior at every aspect. It's the only chassis at this scale which has true shocks, oil-filled, sealed shocks. By the way, I use 150 weight oil in my shocks because that's all I have. I think if you can find 100 weight, it will be better. And it has the smoothest drivetrain in all of my cars. There's no jittering in this chassis. I tried, just out of fun, I tried to bump my gyro up. I went up to almost 90% with no wobble at all. In my BMRX, in my XRX, usually around 65-70, the whole steering will jitter, it will wobble. And that because the TRC has the best or the smoothest drivetrain. It drifts very close to 110 scale. It feels very close to 110 scale as far as drifting. It goes easily around corners, and it drifts very well around large curves. If you can get your hand over one of these, if you can find one of these, 100% get it. You will not be disappointed at all. As I said, ChanRc is your man. He's the authorized international seller for this chassis. It's sold by now. If you contact him, he will tell you it's out of stock from the vendor. But there's a lot of aftermarket places for used RC cars in China. There's a lot of website, and there's a lot of groups, and he has the connection. Just call him. I think you will find he will come up with something for you. And I hope you enjoyed the video. Peace out.